Volume of prisms. A prism has the same cross-section throughout its length. Take this one here. Here we have a hexagon, which is flashing there. That hexagon can be passed all the way through the prism, so that is the cross-section of this shape, and therefore that's what makes it a prism, because it has the same cross-section throughout the shape. So the volume of a prism will be the area of the cross-section times the length. So if we could find the area of that hexagon and we knew the length, we could find the volume of that prism. Triangular prism. Here we have a triangular prism. We can see that the triangle can be passed throughout the length of the shape, and it remains the same. So again, the volume will be the area of the cross-section times the length. Looking at this more closely, we have the base of the triangle, B, we have the vertical height, okay, and we know the volume is going to be the area of that triangle times the length. So we can find the area of the triangle because it's a half base times the height, and then multiply the length by length L. So therefore the formula will become base times height divided by 2 times the length, which is BH divided by 2 times L. A cylinder. A cylinder is a prism which has a cross-section as a circle. So here we have a cylinder, and there I have the cross-section, and I can move the cross-section throughout the shape, therefore it's making it a prism. Looking at that more closely, the length from the centre of the circle to the outside is called the radius R, and this is normally known as H, because normally these are stood up on edge, and therefore the volume is the area of the circle times the length, and therefore as an area of the circle is pi r squared, then the volume of a cylinder is pi r squared times H. Calculate the volume of these prisms. So here you're shown that these are prisms by the cross-sectional area has been shaded in orange. Therefore we can very easily see that these three shapes are prisms. For the volume of the first one, which is just called a cuboid, will be the length times the width times the height. So that will be 4 times 6 times 1, which is 24 meters cubed. One thing you should check when you do these sort of questions, that the units are consistent, in which they are in this case. In the second case we have a triangular prism. However, we are given the area of the base already, so we don't need to calculate it. So the volume this time will be the area of the cross-section, which is 12, times the height, which is 7.5, which gives 90 centimeters cubed. And again the units are consistent because we've got centimeters and centimeters squared. Final case, we have a triangular prism where we know this length is 10, this is 8, and this is 1.5, but we know this angle here is a right angle, so the height of the triangle is 1.5. So the volume is equal to the area of the cross-section times the length, which is equal to a half times the base times the length. So there is the base, there is the height, and there is the length. And there we have that this is a half times 10 times 1.5 times 8, which comes to equal to 60 centimeters squared, and again the units are consistent because they're all centimeters.